All right, so we're going to finish this factoring. Anya, would you mind telling Campbell he has 5 minutes? In Mr. Fair's room. All right. So number 14, this is a clear factoring by grouping because we have a bunch of terms. We don't have a greatest common monomial. We don't have a difference of squares. But we do have this and this. And I notice that they are really similar, but opposites, right? Because this is a negative, and over here this is negative. So I need to do something to switch the signs. And so what I'm going to do here is I'm going to factor out a -1 to this binomial, which means I also have to multiply this by -1. Hope you can read that. So n divided by -1 is going to be -n. -3m divided by -1 is going to be 3m. And I now have a -5p on the outside. I'm going to move this over so I have a little more room. Oh, that negative sign is oh. All right. In that case, I'll just rewrite the negative sign. And so now I have my original binomial, which is n and 3m. And what is in this form right here? Well, that's a 1, because I'm multiplying it by something that doesn't change it. So now I see I have this binomial and this binomial, and they're the same. So that means that 3m minus n is being multiplied by 1 minus 5p. And I'm done. Factoring by grouping at its best. All right. Likewise, if I'm looking at number 15, I notice that I have 4 terms, which is a classic factor by grouping problem. So I'm going to group this together, and I notice that this grouping share a q. So I'm going to factor out that q. So we have q r times r minus s. Now this one's a little trickier. I want r, a positive r minus s, and the signs are switched here. And I also notice that we have an s that goes into both of them. So I'm going to divide out a negative s to both of them. So negative rs divided by negative s is going to be positive r. Oh my god. How'd it go?
I won. And then he won. And he won first.
You're very kind. And we factored out a negative s. And so now I have these two binomials, and they're the same. So I have r minus s, and r minus s is being multiplied by q minus s. Sweet. Now, this next problem is the only time we're going to have a trinomial in a difference of squares. Now, I have 4 terms, which is telling me it is going to be a grouping problem. And I'm looking at this q squared, I'm looking at the t squared. You know what, folks? That really looks like a square binomial. So, to factor that as a square binomial, I'm going to have t minus, because the linear terms minus, 2u. How did I know that? Because what's the square root of 4u squared? 2u. And now I still have my minus 9. Oh boy. This is a perfect square. So is this, and we have our subtraction. This is a difference of squares here, folks. So what's the square root of this right here? I should do that in orange. Whee! The square root of that is just going to be t minus 2u. Sorry that my explanations are less than wonderful right now. I'm in a hurry. And when we have a difference of squares, we're going to take the square root of both terms. Square root of 9 is 3. And so my other term is going to be the same thing, minus 3. So at this point, I have no more simplifying to do. So really, I just have t minus 2u plus 3. And yes, I do need to get rid of the inner parentheses. And t minus 2u minus 3. And there are my 2 terms. All right. So that one I had to factor twice. This one, probably going to have to factor, the rest of them probably going to have to factor multiple times, which is great because you get one problem, multiple factorings, it's a bargain. So greatest common monomial, obviously 4v goes into all of it. And inside, 12v to the third divided by 4v is 3v squared minus v minus 2. I just divided everything out. Now I'm looking at this and I'm willing to bet it could be factored. And this is a binomial, we need a binomial pair of factors, so I know we're going to have this. I know we're going to have a v and a v. That's a negative and that's a negative. And so that means my 3 has to be multiplied by a negative number. And there we have it. And so there's my answer. It does seem like magic, I know, but I know that something times something is 3v squared. 3v times v is 3v squared. 2 times negative 1 is negative 2. And then to multiply it out, there we go, come on, anytime now. 3v times negative 1 is negative 3v. Multiply these together, I get positive 2v. Add them together, and I get negative v. So it works out. There's my answer. All right, next one. I have a binomial that has a, I noticed that they both share a 5, right? So I can factor out my 5w. And this part, most of us should have no troubles doing. And 5w divided by 5w is 1. And 1, that is a square number, folks. This is a square number. We have a difference. This is a difference of squares. So we still have the 5w, and I'll have my difference of squares pair of parentheses. So we get 3w. Oh, crap. Sorry, I didn't just say that out loud. Plus 1, 3w minus 1. And there we have it. All right, the last one I'm going to do very, very quickly. We have a difference. No, because we need to go. So this is clearly a difference of squares. So we have x squared plus 4 times x squared minus 4. This, again, is a difference of squares. So we have x squared plus 4 times x minus 2, x plus 2. And there we go. There is our factoring. And so I'm afraid that's all I'm going to get to today, folks. When you have to factor, or sorry, when you have to solve, remember, quadratics have to be equal to 0 and in factored form. So, and then once you do that, you can actually separate this apart. So this x here is just going to be 7, because 7 minus 7 is 0. Here we got to subtract 5 from both sides. So we get 3x is equal to negative 5 divided by 3 divided by 3. And so this side we get negative 5/3. So this one has two answers, negative 5/3 and 0. This problem here is going to have 3 answers because it's to the 3rd power. You need to move this over, factor, and then set everything equal to 0, and then you'll have